Hey geometry students, I didn't get to finish our discussion today of the construction for the perpendicular line, the demonstration of the perpendicular postulate, and I also wanted to introduce an extra credit opportunity for you. So if you're interested in those things, please watch this video and I'll just get started. So I'd like to do the construction for you of a perpendicular line that passes through a given point. So here's our line, and then this construction works for any point that's not on this line. So I'm just going to choose a spot, let's say here, and I'm going to construct the line that passes through this point that is perpendicular to this line. In previous videos, I have already talked about how to find that line using algebra and analytic geometry. This is the synthetic geometry approach that does not use equations, but instead uses constructions. So for this construction, just as every other construction, you will need your straight edge, which you already saw, and a compass. Here's my compass. I'm using a little metal bow compass, which I think worked the best. So the first step of my construction is to make a circle where the given point is the center of the circle. Now, the radius of the circle is not important. I only need to be sure that it crosses the line in two places that we observe here. So I need to make sure that this circle is going to cross my line in two places that I can see. So I can see now that if I use this radius, that will work. So I'm going to do that now. Here's the arc of that circle. Okay. So I'm going to label these two intersections. Okay, I'll label the original point C for center of the circle. I'll label this point L. And then why not? We'll call these A and B. So our goal now is to construct the midpoint of A and B using the method that we've already used to construct the midpoint of a segment. That midpoint will actually tell us where the segment C, and if that midpoint is M, we'll call it CM. That point will tell us where CM needs to intersect line L in order to be perpendicular. So what I'm going to do, following our construction that we've had in the past, okay, I can use any radius for my compass that is longer than half the distance from A to B, but I'm actually just going to use the distance from A to B as my radius because I think that makes the best construction. So here is my first arc. Okay, the second arc is going to be centered at B, so there's that one. All right, and so the midpoint, or rather the perpendicular, is given here. The midpoint of segment AB is where the perpendicular crosses the line. So I'm going to call that point M. Then here's point M. All right, and so I have that segment CM is perpendicular to segment AB. So I've constructed the perpendicular line. Okay, take a look at that for a second. All right, so for the extra credit assignment for this week, I would like for you to do the following. Given a circle, I'm going to use my compass to construct a circle. I'll call the center of this circle point C, and so here's my circle C. What I would like for you to demonstrate is that for any line secant to the circle, which is a line that looks like this, for any line secant to the circle, a secant line intersects in two places, so two intersections means a secant line. So for any secant line, I would like for you to demonstrate that the secant line is perpendicular to the radius of the circle. So there's the radius. All right, so think about how you might do that, how you might demonstrate that the secant line is perpendicular to the radius. We will certainly use that fact much later in the year when we talk about circles and their properties. So your goal is to demonstrate that any secant line, remember that's a line that intersects a circle in two places. Your extra credit opportunity or your extra credit goal is to demonstrate that any secant line is perpendicular to a radius of the circle. All right, enjoy.